This is 5.8 half angle properties. I went ahead and cut and pasted these onto your notes. They are on the back of your formula chart under the double arguments. Okay, I want you to notice that each of these, you only have sine, cosine, and tangent, that each of these have a plus and minus the square root. Now, this does not mean that you have two answers for each of these, okay? And I'm going to show you what that means. Let me go ahead and write this. Does not mean that you have two answers. Have two answers. You're going to either find the positive answer or the negative answers depending on what quadrant you're in. Okay, one thing that you do have right here is that tangent has three different possibilities that you can use, and I will tell you most of the time that I'm either using the sine over or the 1 minus cosine over sine. Okay, now what this statement right here means is that you're using the half angle or half x, not just plain x. And I'm going to show that right down here. This says x equal 200 degrees. So what does half x equal? Well, half x equals 100 degrees. Okay, so I'm going to go ahead and plot the 100 degrees. So 100 degrees would be about right here. Okay, now I'm going to go ahead and go back to all students, take calculus, to see what sine 1/2, cosine 1/2, and tangent 1/2 are equal to, meaning find the sign of. I want to know if it's positive or negative. Okay, so in these quadrants, what is sine 1/2 x going to be? Is it going to be positive or negative? Well, in this case, sine is going to be a positive. Is cosine of 1/2 going to be a positive or negative in this quadrant? Cosine is going to be a negative. And is tangent of 1/2 x going to be a positive or negative for 100 degrees? And it's also going to be negative. That means if I were to find the value of 100 degrees, I'm going to use sine, I'm going to use the positive here, and for cosine and tangent, I'm going to use the negative. Okay, let's go ahead and find for 480 degrees. And again, this says x equals, so I want to know the half angle of that. That would be 240 degrees. So plotting 240 degrees is going to be in your third quadrant. Go ahead and state all students take calculus. So for sine of 1/2 degrees, your sine of 240 degrees is going to be a negative. Your cosine of 1/2 degrees is also going to be negative. And tangent is going to be positive. All right, so how are we going to use this information? If you notice, they give you a restricted area from 270 to 360. But if you notice, this says theta. So what is 1/2 theta? And that's very important. So half theta is going to be from 135 degrees to 180 degrees. And that should be the first thing that you look at. So this is where my triangle is going to fall between 135 and 180. Okay. So between 135 and 180 is where I look at my restriction. So this is where my 1/2 theta is. Okay. And I'm going to go ahead and figure out if my angles are going to be positive. All students take calculus. If these are going to be positive or negative, just like I did before. So sine is going to be positive, cosine is going to be negative, and tangent is going to be negative, just by looking at this information right here. Okay, it says given that cosine of theta is 15 over 17. Now, they told me from the very beginning that cosine of theta is 15 over 17. But they told me that it fell between 270 and 360. So that's where I'm going to draw my triangle. Okay? So I'm drawing that between 270 and 360. And I know that theta is of cosine is 15 over 17. So that would be 15 over 17. Pythagorean, this would be 8. Okay, using your half argument properties, I'm going to go ahead and find sine of 1/2 theta Okay, and I know that I'm using my positive, so I'm going to do the square root of 1/2, 1 minus, and it says to find the cosine, so my cosine is going to be 15 over 17. Okay, I'm going to keep simplifying. So 1/2 times 17 over 17 minus this is going to give me the square root of 1/2 times 2 over 17. Simplified to the very end gives me 1 over root 17. And again, you don't have to rationalize. This can be your final answer. And again, this answer should be positive. Okay, cosine of my 1/2 theta. I'm going to be using the negative of this because we said cosine of 1/2 theta is negative, square root. Cosine says to use 1/2 times 1 plus cosine of theta. So cosine we know is 15 over 17 again. And I'm going to be adding this. So this is going to be negative square root of 1/2 times 32 over 17. Simplifies to negative 4 over root 17. Again, you do not have to simplify. Okay, so tangent of 1/2 theta. I know that tangent of 1/2 is equal to sine over cosine. So even though it's not written on my formula sheet, I know I can use it. So I'm going to say sine of 1/2 theta over cosine of 1/2 theta. My sine is 1 over root 17 divided by negative 4 over root 17. When I leave change flip, that's going to give me negative 1 over 4. And I know my answer has to be negative because that's what we found at the very beginning. Again, if you wanted to, you could use one of your formulas from the start. Okay, let's try another one. Okay, this says to prove. Of course, this left side looks to be the more difficult, so I'm going to write that down first. So tangent of 1/2 x plus cotangent of 1/2 x. All right. On your formula sheet, remember I said you could use any of the three that they gave you. And if you notice, sine over 1 plus, let's go back to it. Sine over 1 plus and 1 minus. And if you flip either one of these, you get cotangent. So I'm going to use these two. And I'm going to use this for tangent. But I'm going to flip this and use it for cotangent. Then I automatically have common denominators. So this gives me 1 minus cosine of x over sine. That represents tangent of 1/2. Then I'm going to take one of my tangents and flip it. That should be an x. And flip it so that I have a common denominator. So this is 1 plus cosine of x over sine. And now I have common denominators. So I can go ahead and add. That's going to give me, it looks like I'm going to have some things that cancel out. So this gives me 2 over sine x. And if you wanted to take that apart, 2 times 1 over sine x. That would give you 2 cosecant x. That turned out pretty easy. Okay, so this one looks pretty psycho, but looking at my answers, I just need cosine and sine. So I'm not going to replace the answers that they have, those square roots. So I'm going to leave what I have here. So I'm going to start with my cosine of 1/2 x, because this definitely is the hardest side. And leave the bottom as well. All right, so what can I do to make this more simple? And remember, conjugate is multiplying by either the top or the bottom. All right, so let's begin. And I'm going to multiply by the bottom, and it really doesn't matter which one you multiply by. So this would be cosine of 1/2 x minus sine of 1/2 x over cosine of 1/2 x minus sine of 1/2 x. And that's the conjugate. Okay, so now I'm going to put these in parentheses, and I'm going to have to double distribute or FOIL, as some of you have heard. Right, so this is going to give me a cosine squared of 1/2 x minus, this is going to get kind of nasty here for a minute, sine of 1/2 x cosine of 1/2 x minus sine 1/2 x cosine of 1/2 x, and then plus sine squared 1/2 x over. The bottom is going to be cosine squared 1/2 x minus sine 1/2 x cosine, cosine 1/2 x. Looks like we're going to have some cancellation, which is awesome. Sine 1/2 x cosine 1/2 x minus sine squared 1/2 x. Okay, so definitely this bottom section is canceling out. And I'm going to simplify here. How about cosine squared and sine squared? That should give me 1. Let's move up here. Okay, so I've got a property, an Pythagorean identity, so I'm going to say that's 1 minus 2 sine 1/2 x cosine 1/2 x over cosine squared minus sine squared. Okay, now what I see here, I'm going to use a little bit of parenthesis here to see if some of y'all see it. I have 1 minus, but I see 2 sine x cosine x. That is an identity. 2 sine x cosine x. That is sine of 2x. But my x value is a 1/2 x. 2 sine x cosine x is the same as sine 2x. Okay, on the bottom, this is cosine squared x minus sine squared x. That is the same thing as saying cosine of 2x, except for my x is a 1/2. So this was a double angle on both of these, except for my x is a little bit different. Okay. 2 times 1/2 cancels out to give me 1 on both of these. So I have 1 minus sine x, which is nice, and cosine x. And now you're not going to like this, but I think we're going to have to do a conjugate again. How about 1 plus sine x and 1 plus sine x? And y'all are thinking, if there's one on the test like this, I'm going to die. Okay, on the top, how about we get 1 plus sine x minus sine x minus sine squared. Those are canceling. And on the bottom, we're getting cosine. I don't think I'm going to distribute. Just kind of looking ahead. Okay, on the top, 1 minus sine squared over cosine 1 plus sine x. Let's change that to cosine squared and cosine 1 plus sine x. Okay, we can get rid of a cosine. That gives you cosine over 1 plus sine x. Oh, we're there. I was hoping that we didn't have to go further. Awesome. Okay, if y'all have questions, ask them in class.